Hey guys, welcome back. So in this video we're going to talk about our fuel pump and some calculations and how we're going to do the fuel pump. So today we went to the shop and we measured our motor RPMs. Let me pull up some of those results. We found out, let's see, here we go. So this is what we did. We spun the motor. I have a power supply that I supplied about 15 volts, and we measured the motor turning about 3,000 RPMs, and we calculated the kV, which is basically just how many rotations per volt. So you just divide one variable by the other, and we ended up with 200. Nice even number. So 200 revs per volt. So if we give it 17 volts, we'll get about 3,400 RPMs. Interesting number. Interesting because the fuel pump I want to run has a max RPM of 5,000. So I went down here and I said, hey, if we want the pump to spin 5,000, and let's assume the motor has like 2% slowdown or something under load, we end up needing to pulley it up exactly 1.5 to 1. That's a nice pretty number. Okay, so we know that, and that's to get the maximum fuel flow, but the question was how much fuel flow, because on their website their pump is in pounds per hour instead of gallons per minute. So I wanted to convert it. So actually, let me show you. I should still have this picture open. Yeah, here we go. So what I did was I took their picture, which you can see here, they've got pounds per minute, or pounds per hour, I mean, and on the bottom axis down here, this is pump RPM. And what I did was I zoomed in and I drew a straight line going across wherever I thought it intersected. And then in Microsoft Paint, if you move your mouse around, it shows these pixels. Sorry, see how this moves? So you can actually pick up the X and Y position. So what I did was I got the position, like the Y-axis position of 0 and the Y-axis position of 3,000. And then like here, I'd move my mouse until it was right on this line or right on that line or whatever. I'd get it on there and write down the number. And when I did that, this is what I got. So those are the numbers. So once we knew that, I'll show you. We went into Excel. Yeah, I believe that's over here. Yeah, we went into Excel. These were the numbers. Now we calculated the slope earlier, and it was this number. And this was the offset, so basically 0 was 947. So to calculate pounds per hour, you just take the difference in those two and multiply it by the slope. So that equation, that gives you pounds per hour. And let's see, once we had that, we converted it to gallons, and that was the answer. Now we kind of did that for a couple reasons, but I wanted to get a graph of this just to make sure that, you know, I could represent this and I was doing it right. And this is what we found, so check it out. Our 6 gallon per minute pump is actually going up to almost 6.6 gallons a minute, which is interesting. A little bit of bonus. We're getting full flow at 4,500, so that's nice. Well, I didn't actually expect that, so that's kind of cool. Now these numbers are at 60 psi, and I'll probably be running 80 to 90 psi, which means I am going to have a little more pressure, and that means you'll probably get slightly less flow. That's probably not a lot, maybe 5% or something. But anyway, we got those numbers, and what we notice is, you know, we should get 6 gallons per minute. Now, let me show you something. We're going to go to a different sheet real quick. This one. So I've got some tabs down here. Fuel burn at different mass flow rates. So I did 80, 100, and 120. Now, for those of y'all, some of y'all are going to know this, some of you probably heard it. A quick, easy thing. Pounds per minute, this is air. So if you've got 80 pounds per minute of air, that means you can basically make 800 wheel horsepower. Now my turbo says it caps out at 64 pounds per minute according to the compressor map. But the turbo that I run is an EFR from Borg Warner, and I've seen turbo maps from them that say they cap out at 400 or say 40 pounds a minute, and people make 400 to the wheels or more. So I went ahead and bumped this up from 64. I was going to do like 70. I just went ahead and went to 80. That's more than I'm going to be able to make on this turbo, but I just did that. Plus it makes for even numbers. The 120 number comes because in the future, I'd like to try to set the car up to make 1,200 wheel or at least 1,000 wheels. So that's where these numbers come from. So let's start with 80 pounds a minute. So that gives us 80 pounds per minute of air. I think the richest air-fuel ratio we'd run is a 3.4, and that converts to be about 23 pounds per minute of fuel. We know the density of methanol is 6.6, so that works out to be about 3.5 gallons a minute. which is pretty easy to do with our pump. And you can see over here, just for reference, we converted that to liters per hour, so that's 810. So just a little fun fact for y'all. I was kind of curious. I wanted to put this in terms of some numbers that are kind of relatable to a lot of Miata people, especially when you're first getting in the game. I looked up the old Walbro 255 HP. I used to run this pump for years, and in fact, when I upgraded, I just went to twin Walbros. These are great pumps. They're real reliable, they're affordable, they work pretty well. So the 255 HP, it's known for its performance at high pressure. So this pump at 80 PSI would still kick out 210 liters per hour, which for a 255 pump, that's actually pretty good, because a lot of pumps, they really fall off with pressure, but this little guy will go over 100 PSI and still be pretty usable. So that's kind of awesome. But just for reference, this setup would need 810, so you'd have to have 4 of those pumps. But the thing is this pump is not actually rated for methanol, and in fact, most pumps aren't. And that's kind of why we're doing this. So next we're going to go to a different tab. This is the 100 pound per minute. So here you can see this is going to pump all the numbers up. We ended up with a little over 1,000 liters an hour. Where's our gallons per minute? 4.45, about 4.5. And lastly, we're going to go to the 120. So this is if we made 1,200 wheel. We would need 5.3 gallons a minute, a little over 1,200 liters an hour. So we can see, even if we were making crazy power, 1,200 wheel, and we needed a little over 5 gallons a minute, that 5.3, if we go back to our fuel pump, 5.3 gallons, we can do that at 4,000 pump RPMs. Barely. So you'd want to run it faster than that to have some safety, but you can see, even at 6, you've got some headroom, and this pump will go higher than that. So what that tells us is we probably don't actually have to run this pump at 5,000 RPMs. That was the findings. I didn't expect this to be true, but it actually is true. So if we go back to what we're doing now, this 80 pounds a minute, 3.57. So that's how many gallons we need. Now we can add some safety factor because we're definitely going to need it. So 3.5, let's add 20% to that. What would that be? 0.7, 4. Let's just go with this number, 4.2. So that's 3,000. Now our pump will turn 3,000 at 15 volts. It'll turn 3,400 at 17. So what that means is I could do a 1-to-1 on this pump. So either direct drive, which I'm probably not going to do, or more realistic, I'll do a chain and sprocket or a belt and pulley, but I'll just do a 1-to-1 connection. Now the good thing about that is I'll be putting less load on the motor, because if the motor's 1-to-1, say if we did the 1.5-to-1, that means every time the pump spins 1 rev, every time the motor spins a rev, the pump spins 1.5. That way when our motor gets up to its maximum of 3,400, our desired pump would be at 5,000. That's great and all, but that puts more amps into the motor, more load on the motor, and we really don't need it right now. So what I think we're going to do is we're just going to do a 1-to-1. That'll give us, we can go up to 3,400 on the pump, which is pretty close to 3,500, which we can see is about 5 gallons a minute. So even at 1-to-1, we can get damn near 5 gallons a minute. Would that even hit our 1,000 horse goal by chance? I don't remember the numbers. Let's check. Go to 1,000, 4.45. That actually would. So even with the 1-to-1, well, that'll probably get us to 1,000. Not with a lot of headroom, but it would do it. So that's pretty cool. And that's what we're thinking. We're going to set this sucker up 1-to-1. Let me show you what we're going to use. So this is McMaster for those of you that have never used them. If you got to build stuff, like you need bolts, materials, odds and ends, they got a lot of stuff here. Their prices are meh, but they have it, and their website's awesome, and they ship pretty quick. So here's some sprockets. If I go to this tab here, nope, not that tab, this tab. Here's a whole list. So you can sort these by different things. I've got these set for ANSI 25 roller chain, and you can literally just pick the number of teeth. So if I want a 30 tooth, you go here. You can see they got different bore diameters, 3/8, ½ inch, whatever. And then if you go across, these things are like 20 something bucks. So real cheap. We had planned to use a belt and pulley, but I can't find like belts and pulleys that are appropriate, that are even available. I can find the pulleys, but I can't find the belts. So I think we're just going to do this. It's a little baby chain. It's real small, but it'll be fine for this application. It possibly might be noisy, but I kind of doubt it. I bet it'll be fine. So I think we're going to do this. something cheap, and basically just buy a couple of these. The motor has a goofy shaft size of like roughly 12.5 millimeters. So what I think we're going to do is we're just going to buy a couple of these sprockets with a small bore and machine them to the spec we need. That way they're a nice tight fit and everything's concentric. And we got a machine, it won't be hard to do that. So pretty sure we're just going to do that. But like I said, what's great about these is they're not expensive, you know, $20-something, and they're in stock. And chains are easy too. You can basically make a chain and put a link in it. That's easy to do as well. So I'm liking that. That's kind of our plan. Get the fuel pump connection going, and that'll be great. Get our have our fuel pump going. So this is all looking good. After turning that pump on today and seeing how it performed with the RPMs, I was very happy because I had read on Google that the kV of this motor was really low, and that had me concerned. I was kind of bummed. I was like, man, that motor's not really, you know, I was wishing it spun faster. Well, I kind of got my wish. It's actually faster than I expected. So we're all good. Now I feel like this is going to work great. So I guess that's going to sum this up. Probably tomorrow we're going to go ahead and spec the rest of these parts and order the sprockets, order the fuel pump, and we'll get this sucker going. So anyway, hope y'all enjoyed, and until next time, y'all take it easy.